Now, the last couple of lessons we've been talking about the global wind, and it's important not to get confused. Global wind explains what direction the weather patterns move around the globe, and it also determines which way the water moves in the ocean currents. But much like a herd of elephants moving across the savannah, it's possible that while the elephants are moving one direction, an individual elephant in the pack is moving all different directions. When we talk about wind, we have to also talk about what scale or size of the wind we're looking at. While we just were talking about global winds, in this lesson, we're going to talk about local winds that are also based on temperature. When we talk about winds, it's real important to realize that you always mention the direction the wind is blowing from. So in a north wind, you would face the north to have the wind hit you in the face. A west wind blows out of the west. A south-southeast wind blows just a little east of south. That's the direction you have to face in order for it to hit you in the face. Locally, we're going to measure wind with something called an aerovane. There's a part of the aerovane that will point in the direction that the wind is blowing from. That's the wind vane portion. And then a little propeller on the front, which will spin faster as the wind speed increases. That's an anemometer. Combine that together, you get the aerovane. The largest wind vane in the world is located in Montague, Michigan. That's me standing underneath it. And in fact, it does work. Drew Anderson was recently there, and he actually saw it in action.
Love with a capital L, that sky. Look how blue it is. That's just the perfect color blue. Nice little ornament right there, or something like that, right? In Montague, Michigan. It's not an ornament. Instead, let me back up. Wait for it. Wait for it. Here it comes. You ready? It is the world's largest weather vane. And yes, it is actually moving. Watch the ship. It's a little bit breezy right now. And the ship, it's pitter-pattering a little bit here and there. I guess in between north and west, more so north than anything. Oh, there you go. There it is moving right there. Pretty cool. Pretty big, too. I mean, check it out. There's a car for scale. There it is. And there's the top of that thing.
Now, in local areas where we have big temperature differences, we can have a local wind that establishes itself and is very, very constant. One example of this is the sea breeze or the land breeze. We don't get those in Lancaster or Hempfield in Pennsylvania. You have to live by a large body of water in order for this to happen. And basically, we have warm air wanting to rise and cold air wanting to sink. And when you live by a big body of water, the water is going to change temperature much slower than the land does. So imagine a warm afternoon with the sun beating down on the earth. The sun heats the ground, and that ground will get warmer than the water next to it. Warm air wants to rise. So over the land, that air lifts up a little bit, and the breeze comes off the cool ocean to replace it. This will happen throughout the afternoon and into the evening, where you'll get this constant breeze coming off the ocean. Once the sun sets at night, everything reverses. The land is going to cool faster than the water. If you've ever gone in the ocean or a pool at nighttime, it's usually warmer than the air you're in. So in that case, we'll have the warm air rising over the ocean, and the cool air will come off the land to replace it. That's a land breeze. It's coming off of the land. This happens frequently in Florida. They have sea breezes on both sides from the Atlantic and the Gulf, and they meet in the middle. Where we have the wind coming together, that's convergence, and convergence makes clouds. That's why in the summertime you can frequently set your watch to thunderstorms in the Orlando area. Typically about 4 o'clock in the afternoon you're going to get a storm. Here's some proof. Look at the clouds only forming over the land in Florida, not even Lake Okeechobee there in the south. And this is a typical converging thunderstorm that forms there in Florida. A second type of local wind is called a monsoon. Again, not a type of wind that we have here in southern Pennsylvania. But monsoons are simply a really large land and sea breeze. So let's look at the Indian Ocean. The land is going to get very warm in the summertime. So all of India and all of Bangladesh, you have that warm air rising. especially rising up the Himalaya mountains. That's going to create an awful lot of clouds and water. A lot of rain occurs in the summer months. In fact, Cherrapunji, India gets almost all of its rain in the summer months. In the winter, we flip it around because the water is warmer than the land, so it's very, very dry. The wind is blowing down off the Tibetan Plateau, down off the Himalaya mountains, and that creates dry conditions. A dumb and useless fact, that town that was just on there, Cherrapunji, India, once got 87 feet of rain during the monsoon of 1861. 87 feet! Lancaster doesn't even get 3 feet of rain in a given year. They got 87 feet in just 6 months. We do have monsoons in the United States. They're typically in Phoenix and in Arizona and some parts of New Mexico. We have the Gulf of California, and that doesn't warm or cool as quickly as the desert Southwest. So in the summer, we'll get periods of rain in the afternoon in the deserts. The third type of local wind is called a katabatic wind. Katabatic wind usually comes from a place of ice that's very, very cold, and cold air wants to sink. And if that ice is trapped in some kind of mountain basin, that cold air will accumulate, kind of like filling up a bathtub before it finally spills out over the side and sinks down. Again, this is not something we have in Lancaster, but it's common in areas where there's ice a lot of the year round. Here's a movie from Iceland. Now, since the wind is blowing down, you shouldn't have a cloud there. Understand it's blowing the fog off the mountain down into the ocean. But that fog is drying out as it's descending. It's just a marker there. You can see the wind and hear it blowing down over this ice-covered plateau off the mountain into the sea. From the ice to the desert, a haboob is a dust storm, where a gust of wind picks up a tremendous amount of dust and it can make visibilities very, very hard to see.
The art of marriage,
this is a popular movie of a wedding ceremony that took place as a haboob moved in. Take a look on the groom's face when he realizes what's about to come.
Jennifer and Gustavo, you have today joined your excuse me.
Go ahead. You can skip some.
Yeah. We'll do the sand ceremony now.
Okay.
Jennifer and Gustavo today will join separate lives together. The two separate bottles of sand symbolize your separate lives, separate families, and separate sets of friends. They represent all that you are and all that you will ever be as individuals.
How ironic they're doing the sand ceremony as the dust storm blows in.
As these two containers
this can cause a lot of traffic headaches in the desert Southwest. But again, we don't get a lot of that here in Lancaster. If you know any relatives that served in the desert storm, they typically get those over in Iraq. Another type of wind not around Lancaster is a Chinook wind, typically found in the east slope of the Rockies, where you have wind blowing up a mountain, which creates a cloud in that rising air, and you have strong wind over top of the mountain, which kind of squeezes the air through the middle, and it sends it racing down the other side of the mountain. As that air descends, its pressure increases greatly. Remember that relationship with pressure and density and temperature? Now that the air is really, really dry, the relative humidity or density won't change. We keep that fixed. So as the pressure goes up, the temperature has to go up. And it gets really, really warm on the other side of the mountain. It's called the Santa Ana if it goes the other direction. And the Santa Ana wind in California can create a lot of problems with forest fires. In Switzerland, it's called a Föhn, or in the German language, it's a Schneefresser. If you speak German, that's snow eater, Schneefresser. The Santa Ana, again, is the opposite of the Chinook. It brings dry, warm air down to Los Angeles, and usually that dry air enables fires to ignite, and that's where we get bad fires in the Los Angeles region. There's some smoke from some of the fires in the Santa Ana winds back in 2003. There was actually a football game that was supposed to be held at the Star where the SD is, the San Diego Chargers. They had a Monday night football game that they actually had to cancel and move to Phoenix because the smoke was so bad. Okay? Santa Ana winds. This is how bad the Chinooks can be. In Granville, North Dakota in 1918, at 8 a.m., the temperature was 33 below zero. Then a Chinook kicked in, and it got up to 50. That's a difference of 83 degrees. Spearfish, South Dakota, January 22nd, 1943. At 7:30, it was 4 below. At 7:32, 2 minutes later, it was 45 degrees. It got up to 54 by 9 a.m., and then at 9:34, it was back down to -4 because the Chinook had stopped. The plate glass windows cracked in town because the temperature changed so quickly. Lead, South Dakota and Deadwood, South Dakota are only 1.5 miles apart. That's the difference from Hempfield High School to Centerville Middle School. In Lead, South Dakota, it was 52. In Deadwood, it was 16 below. That's the thermograph of the temperature on that day. So let's go back and review what we've done in this module. Global winds, prevailing winds, move the weather. Global winds are caused by unequal heating of the Earth, which creates changes in density. Earth's rotation bends the prevailing wind through something called the Coriolis effect. Those global winds blow on the water, and that makes ocean currents. When global winds change, the currents change, causing these oscillations. We discussed the El Niño, La Niña, the NAO, and the AO. And seasonal winds are caused by local changes in temperature, the sea and land breezes, monsoons, and katabatic winds. Wind direction is measured by where it blows from. So to this point, we've discussed a couple physical properties of air. The air has temperature and the air has density, which combined help create these global winds. Next, we're going to look at an important property of air pressure.